Welcome back, AP Statistics. This is the second half of Chapter 2. We're talking about contingency tables. This is an example of a contingency table. It's also called a two-way table. The variables are survival and class. All right, so we have survival over here for my two rows, alive versus dead. And class is my other variable, and its values are first, second, third, and crew, and those comprise the columns. Each cell of the table gives account for the combination of values of the two variables. For example, this 203 right here is a cell, all right? It's the combination of first, class, and alive, survival status. Another example, 212 right here is the intersection of crew and alive. So everywhere we're looking at an intersection of two variables, we are talking about a cell. The columns show how many people survived and how many people died contingent upon their class. So second class. This column says 118 were alive and 167 were dead, totaling in 285 people in the second class. The rows show how many people were in each ticket status contingent on their survival status. So let's look at the row of the dead. Go back for a moment. Let's look at the row of the dead. 122 out of 1,490 were from first class, 167 out of 1,490 in the second class, and so on and so forth. The columns on the far right and the row at the bottom, so the column on the far right and the row at the bottom, those are called the margins, okay? So these sections give totals. This 711 is the total number of people who were alive. This 706 is the total number of people who were in the third class. The number at the bottom right, this 2,201, as I've mentioned before, is the total number of participants, subjects, etc. That is often referred to as the grand total. Sometimes contingency tables feature percents or relative frequencies. This contingency table features the percent of total people in each cell and in the margins. So for example, what proportion of people were in second class and alive at the same time? Well, that's 5.4%. How many people compared to the total were in the crew? 40.2%. Right? So there you go. We can represent these data as percents or as raw data. Marginal distribution. The frequency distribution of one of the variables expressed in the percent of the total is called the marginal distribution, right? Let's put an example to this. So for example, the marginal distribution of survival is, well, this right here, okay? Well, what does that mean? Well, let's look at where these numbers are coming from. 711 out of 2201. Here's my 711. And here's 2201. We are doing the marginal distribution of the variable survival. So we have survival, alive versus dead. 711 people were alive out of 2,201. Let's look at the second ratio here. 1,490 out of 2201. Well, that's this number divided by 2201. So that's the proportion of the total who were dead, okay? So the marginal distribution for the variable survival is what proportion of the total were alive versus the proportion of the total who were dead after the Titanic hit the iceberg. So now we're going to find the marginal distribution for the variable class. Now, to give you a hint, you're going to find 4 different values. Take a moment, see if you can find the marginal distribution of the variable class. Pause the video, unpause it when you think you have an answer. Okay, I'll assume we're ready to continue. Here we go. 325 out of 2201 were first class. That's this 325 out of 2,201. 285 out of 2201 in the second class, 706 out of 2201 in the third class, 885 out of 2201 in the crew. All right. Now we're going to talk about conditional distribution. This is a little more messy than what we've done before, but not by much. You'll get it. A cruel fact of the Titanic story is that the chance of surviving depended on one's class. And we will see that very vividly in the next couple slides. This is revealed by analyzing the row percentages, and then later we're going to look at the column percentages. All right, and between those two, you're going to get the idea. All right, the percentages in each cell in this table right here correspond to the total at the right margin. Okay, so these are called row percentages. All right, and they correspond to totals on the right hand side. That's why we have 100% here and here. Now, what do these percentages mean? Let's look at this 28.6. This means that of the people who were alive, all 711 of them, 28.6%, or 203 to be exact, were in the first class. All right? Out of the total people who were alive, 16.6% were in the second class. And out of the total people alive, an even quarter were in the third class. And out of the total alive, 29.8% were in the crew. All right? Now let's look at the dead, and here's where the data really start to speak, okay? Especially when we compare the raw data and their conditional, the class contingent upon the fact that they were dead, okay? Of the dead, 8.2% were first class, 11.2% were second, 35.4% were third, and a whopping 45.2% were the crew. Let's keep something in mind here, all right? 45.2%, half, pretty much, of the people who were dead were in the crew. And where this really starts to speak to the injustice of the matter is when you look at the 212 versus the 673. Pretty much 75% of the crew died. Nearly half of the people who died were in the crew. That's crazy. The conditional distribution, to give it a definition, of one variable by another shows the distribution of one variable given values of another variable. So you'll see the word by a lot. And by means given. And given means we're living in a particular world, as it were. In other words, the conditional distribution of the variable class given survival status can be seen in the percentages in the cells. Okay? So given certain survival statuses, given that we are in the world of the living, these 711 lucky folks, these percentages are the breakdown of just the living, given that we are in the world of the living. Now, given we are in the world of the dead, these comprise the breakdown of that. All right, so conditional distribution, we're living in a particular world, the world that is given. Then we analyze the breakdown within that specific world, whether alive or dead. Okay, and we can graph this in another way. We're going to use a bar chart here, classic bar chart. And here's where the data really start to speak if they haven't already spoken before. Let's look at the alive folks. You got first, second, third, and crew. Okay, given that you were alive, there's almost a 30% chance that you were in the first class. There's also around a 30% chance that you were in the crew. There are way more crew than first class. There are way more crew than first class. There are almost 900 crew. There are a little over 300 first class. Okay, there's 325 first class. That's bonkers. Now let's look at the dead. This graph screams injustice, okay? Look at this. If you are in the dead category, look at how high crew is. Yes, crew comprise the highest percent of people aboard the boat, but that's just uncalled for. All right, contingency tables, conditional distributions. Now we're looking at the column percentages. So given we're in a particular class, what are the odds that we're alive, and what are the odds that we're dead? Okay? This is the conditional distribution of the variable survival status given class. So we're going to be living in the world of first class. What proportion's alive, what proportion's dead? In the world of the second class. What proportion's alive, what proportion's dead? Okay? So that's the difference between column percentages and row percentages. You just flip the condition, all right? What world are we living in versus what breakdown are we analyzing, okay? If these conditional distributions were organized into a segmented bar chart, which is a very useful graph for letting these data speak, we would see that one's class influenced the likelihood of survival. Check this out. So we're living in the world of crew. If you're in the crew, what are the odds that you're dead? Over 75%. First class. We're living in the world of first. All right? Who seem to have put themselves first. All right? Less than 50% of them were dead, and they are the only class that can say that. Second class, somewhere in the middle. Third class, you're almost as bad off as the crew. Not quite, but almost. Okay, so now we're going to start putting all the pieces together. We have marginal distributions, conditional distributions. Let's go. The table to the right shows the results of a poll asking adults whether they were looking forward to watching the Super Bowl game, just the commercials, or didn't plan to watch at all. What is the marginal distribution of the responses? The responses being you want to watch the game, you just want to watch the commercials, or you don't want to watch at all. Take a moment, pause the video, try this one on your own, and then unpause the video to check your work against mine. Okay, I'll assume we're ready to continue. The correct answer is that. All right? Check your work against mine. Move on whenever you're ready. Okay, let's continue. Find the conditional distribution of the 3 responses for men. That is the distribution of response given male. All right, I'll give you one bit of this. We are looking for the distribution of response given male. So we are living particularly in the world of men. So 492 is your grand total, not 1,008. 492 is your grand total. Try this one on your own and unpause the video whenever you think you have the correct answer. Okay, I'll assume we're ready to go. Here's the answer. Check your work against mine. Move on whenever you feel ready. Alrighty, last one. How do the conditional distributions of interest in commercials differ for men and for women? In other words, how does commercials given male compare with commercials given female? All right? Look at the conditional distributions of commercials for men and for women, specifically commercials given male versus commercials given female, and see what you think. Unpause the video when you think you have an answer. Okay, let's look at the answer. 81 out of 492. Well, where's that coming from? Well, let's look at commercials given male. We're in the world of male, so our total is 492. Of those 492, 81 are in the world of commercials. Okay? As compared to 156 out of the 516 women, that would be the conditional distribution of commercials given female. There are 516 ladies, and we have 156 of them who are just interested in commercials. Honestly, you can take a good gander at those fractions and realize that 156 out of 516 is bigger than 81 out of 492. You can throw it into a calculator if you would like. Bottom line is, it's more likely for women to be interested in just the commercials than men. That's what we have learned in this exercise. All right, now we're going to talk about something just as lighthearted, politics. Just kidding. Okay. We say that two variables are independent if the distribution of one variable is the same or almost the same, technically. More on that later. It has to be the same within a certain tolerance. We'll talk about that at the end of the year this year. All right. By the way, if you hear some noises in the background, that is my son, Cody. So please pardon him as he wakes up from his nap. All right. For all categories of another variable. All right. So independence means that the distribution of one variable is the same or technically almost the same for all categories of another variable. All right. In other words, it doesn't matter who you ask, the likelihood of each possible outcome is consistent. So it doesn't matter if these two variables, whether the sex of the person or their political leanings, doesn't matter whether you ask a man or a woman. The distribution of Republican, Democrat, or Independent would be the same if the variables sex of the person and political leanings are in fact independent. Okay? So below is a table with data demonstrating that in a particular survey, maybe not in all surveys, but in a particular survey, the variables sex and political affiliation are independent, right? In other words, the conditional distribution of affiliation given male is about the same as that of affiliation given female. Okay? So in this table right here, let's look at affiliation given male. So we're going to live in the world of male right now. And let's look at these proportions. We have 120 out of 250 being Republican, 90 out of 250 being Democrat, and 40 out of 250 being independent. We are in a red part of the country, you might say. All right. Now let's look at the ladies. 110 out of 250. Conveniently, we sampled the same number of men as women in this totally contrived survey. 110 out of 250 would be the odds of Republican given female. That's very close to 120 out of 250. All right. So for Republican, it didn't really matter who we asked. There you go. For Democrat, you have 95 out of 250 versus 90 out of 250. So you could look at that and you say, oh, there's a slight preference for the ladies to vote Democrat over the men, slight preference of men to vote Republican over women. All right. But is that a significant difference? Okay. We'll be able to answer that objectively later on this year. To be entirely honest, I've done enough statistics. I can just so much as look at that table and say there is no chance this table is going to register as not independent, that there is some association between whether you're male or female and what political leanings you have. These variables are independent. Speaking of independent, works for the independent category as well. 40 out of 250 men, 45 out of 250 women. Again, it doesn't matter who you ask. The proportion is virtually the same. Right. The segmented bar chart to the right, this guy, demonstrates even more strongly, because it's a graph, that there's no association between the variables. This segmented bar chart right here, look at Republican, 120 versus 110 out of the 250. These bars are, noticeably different, but that happens with real-world data, all right? 90 out of 95. 90 compared to 95, all right? Those numbers are different, but they're not very much different. 40 as opposed to 45. In the grand scheme of things, since we sampled a pretty large sample, 250 people in each category, it's the size of a small town, or a village or something like that, you have about the same proportion of men and women voting Republican, Democrat, and Independent, meaning that those variables, the sex of the person and their political leanings, are independent. Doesn't matter who you ask, the proportions of each political affiliation will remain about the same. Okay? All right. Now we're going to look at a non-example of independence. Here we go. This is familiar. This is talking about men versus the ladies in their response to the Super Bowl. Are they going to watch the game? They just want to watch the commercials, or they don't want to watch it all? Does it seem that there is an association? By the way, what does that mean? There's an association. That's the opposite of independence. Independence means it doesn't matter who you ask. It doesn't matter whether you ask a man or a woman. The distribution of game versus commercials versus won't watch is going to remain the same. And also, it doesn't matter whether you're worried about watching the game, commercials, or not watching at all. The proportion of men and women in each of those categories is going to remain consistent. Okay? So that is what independence would mean. Independence, if one variable is independent of the other is independent of the one. Independence would go both ways in that sense. All right? So, and we'll talk more about that later. Okay, do you think these two variables are independent? Now, if these data are not talking to you, which, I mean, it's a two-way table. It's focused on content, not necessarily displaying it powerfully. Look at this segmented bar chart. This segmented bar chart is speaking, all right? Over here, won't watch, there's a difference, but it's not much. The difference in commercials, wow. We've already talked about how if you're looking at people who are not interested in commercials, it's more likely that you are female than male, all right? And flip that around and you have watching the game, all right? Men are, given all the men, more than half are interested in watching the game, as opposed to a significantly smaller proportion of women. So does it depend on who you ask? Are you more likely to get or less likely to get a certain result? Watch the game, just watch the commercials, don't watch it all. Are you more or less likely to get certain results depending on whether you ask a man or a woman? Yes, all right? These bars are very, very different. These, not really, but the rest are, and that's not uncommon. If any of the sets of bars are different, that is an indication. I'm not just saying a little different, I mean very different. That is an indication that the variables sex and response to the Super Bowl are not independent, okay? So let's break it down. About the same proportion of men and women won't watch. Ho-hum. However, among those watching, there appears to be an association. All right, that's the opposite of independence. Independence says, doesn't matter. The proportion's going to remain the same. Association says, no, it does depend on who you ask. All right? So, it does depend on who you ask. There is an association between the viewer's sex and what they're looking forward to watching while the Super Bowl is airing. Women are much more likely than men to be looking forward to watching the commercials, almost twice as likely. Whereas men are much more likely, not twice as likely, but maybe 1.5 times as likely, somewhere around there, than women to be looking forward to the game itself. That said, the interest in Super Bowl TV coverage and the person's sex are likely not independent. And I say likely because we have not performed the correct statistical procedure to demonstrate this is so. So we can only say they are likely not independent, although I will tell you, I'm pretty sure they're not independent, all right? This segmented bar chart is screaming association. It does matter who you ask. All right, and there's the homework. I will see you in class tomorrow. We'll get a chance to work on this homework together. You can start it ahead of time or just be prepared to work on it in class. Have a great day.